By now, I bet everyone knows this guy. Yes, it's Jupiter. In our solar system, the Sun's the boss and Jupiter's second in command. We all know Jupiter is huge, but just how huge? Put it this way. If Earth was an 8mm peanut, Jupiter would be a football or basketball, and the Sun would be a balloon about 1.2 meters across. Mass-wise? Apart from the Sun, take all 7 other planets, multiply by 2.5, and you're close to Jupiter's mass. Despite its massive size, Jupiter is basically a giant gas ball. 90% hydrogen, 10% helium, pretty much the same recipe as the Sun. But here's the crazy part. Calculations show that if Jupiter had absorbed just 80 times more mass during formation, its metallic core could have triggered nuclear fusion. Jupiter would have ignited, turning our solar system into a binary star system. But it missed by just that much, leaving Jupiter as a gas giant. It's like Jupiter was perfectly designed to protect Earth. Can't become a star, but has this massive body and magnetic field sitting right at this crucial sweet spot. Many of you have heard Jupiter called Earth's guardian. Why? How intense is the pressure inside Jupiter? It's so crazy that hydrogen gets squeezed into liquid metal. Add Jupiter's insane spinning speed, and you've got yourself a giant power generator with a magnetic field 20,000 times stronger than Earth's. As carbon-based life forms, we can't really sense this powerful field. But Jupiter's real protection comes from its massive gravitational pull. Small comets trying to reach Earth through Jupiter's orbit? Most get caught by Jupiter. Take the 1994 example, Comet Shoemaker-Levy 9. This comet was half the size of the Chicxulub asteroid that wiped out dinosaurs 65 million years ago, about 5 kilometers in diameter. As it headed toward Earth, Jupiter's gravity captured and ripped it apart. Earth's observatories watched it tear into 21 massive chunks that slammed into Jupiter. The biggest piece was 4 kilometers across, with impact energy equal to 60 trillion tons of TNT. All 21 pieces combined. That's a mind-boggling 400 trillion tons of TNT equivalent, about the same as detonating 50 Hiroshima bombs every second for a year. Compared to the dinosaur-killing Chicxulub impact, this was 40% of that energy. Models show if Shoemaker-Levy 9 had hit Earth, 75% of all species would have gone extinct. Some humans far from impact might survive, but they'd face long-term famine and societal collapse. Impact dust would block sunlight for months to years, dropping global temperatures 10 to 20 degrees. If extreme weather lasted decades, humanity would likely regress to small tribal communities. Actually, Shoemaker-Levy 9's chance of hitting Earth was basically zero. Starweaver is just using it as an example here. Hope you guys understand this correctly. Over billions of years, Jupiter and our Moon have indeed blocked countless impacts from reaching Earth. Jupiter's powerful gravity doesn't just give it 95 moons. It also shapes Jupiter's faint ring system. These dusty rings aren't as spectacular as Saturn's, but they quietly tell the story of our solar system's gravitational ballet. Jupiter's moons are fascinating. Io is the most volcanically active body in the solar system, with over 400 active volcanoes shooting sulfur plumes, 500 kilometers high, basically a giant fireball. Europa is wrapped in thick ice, hiding more liquid water beneath than all Earth's oceans combined. Essentially a water world. It's also the only place besides Earth that might harbor life. Ganymede is our solar system's largest moon at 5,262 kilometers diameter, bigger than Mercury and the only moon with its own magnetic field. Callisto, cratered diary of 4 billion years. Virtually no geological activity. It's like the solar system's notebook, silently recording billions of years of history. Once Starweaver finishes covering all 8 planets, we'll circle back to explore these amazing moons in detail. Earlier I mentioned Jupiter's 10-hour rotation. Actually 9 hours, 50 minutes. While Earth completes 1 rotation, Jupiter does 2.5. This incredible spin creates super hurricanes over 600 kilometers per hour on Jupiter's surface. Various chemicals mix and swirl in these storms, creating those red, yellow, and white stripes we see. Why different colors? Still no definitive answer. One theory: light-colored zones form from rising clouds of ammonia ice crystals, while dark belts form from sinking clouds. Jupiter's ultra-high rotation makes these cloud bands race parallel to its equator at hundreds of kilometers per hour. This relative motion creates cyclones and storms of various sizes. The biggest is the Great Red Spot, big enough to fit 3 Earths side by side. This storm has raged for at least 350 years, sustained by Jupiter's internal heat convection. But why is it red? How long will it last? We simply don't know. As of May 2025, humans have sent 8 probes to Jupiter since 1973, with Juno and Europa Clipper rewriting textbooks. Only Galileo, Juno, and Europa Clipper are dedicated Jupiter missions. The others just flew by. Europa Clipper is worth a special mention. Launched October 14, 2024, expected to reach Jupiter's orbit in 2030. Its main goal? Detecting whether life exists beneath Europa's ice. It'll also study Jupiter itself. As mentioned, Europa is an ice-covered water world. Based on Galileo and Hubble observations, the subsurface ocean is 50 to 150 kilometers deep with twice Earth's water volume and Earth-like salinity. The seafloor has active volcanoes providing energy and minerals. The ice shell and atmosphere effectively shield against Jupiter's intense radiation. These conditions create a long-term stable environment for ocean life. Most exciting of all, probes detected sulfur compounds, organic molecules, and possible biological metabolites in Europa's ice geysers. If Europa Clipper actually finds life on Europa, human space exploration will take a giant leap forward. So far, Starweaver has covered Mercury, Venus, Mars, and Jupiter. Most probes exploring these planets came from ESA, the United States, the Soviet Union, and other countries. Speaking of Jupiter exploration, we Aussies haven't been sitting around doing nothing either. The Parkes Radio Telescope didn't just help Apollo 11. It's still tracking Jupiter probe signals right now. Sure, Australia might not have a huge population, but when it comes to space exploration, we never mess around. From pioneering radio astronomy to today's excellence in space technology and satellite communications, Australia proves that small nations can make big noise in space exploration. If any young friends are watching my videos, Starweaver hopes you start nurturing great dreams right now. Every great dream starts with today's hard work, so keep running. Keep reaching for the skies, my friends. Your telescopes, experiment kits, plus Australia's exceptional stargazing conditions and deep scientific traditions might just be the starting point for future breakthroughs in human understanding. Under these Southern Cross skies, let's look up at the stars while keeping our feet on the ground. The future truly belongs to you. This is Cosmic Canvas. I'm Starweaver. If you love space exploration and unsolved mysteries too, please like and subscribe. See you next time. Love you all. Bye-bye.